Okay, we look at this example where we apply right triangle trigonometry to an application. Um, this person is trying to find the height of a tree. All right, so the person wants to see how tall a tree is. And what the person does is the person walks to a point 30 feet from the base of the tree. She measures an angle of 57 degrees between the line of sight to the top of the tree. And the ground below. Find the height of the tree. All right, so I mean, as far as that line of sight language, that's something right there. But so what's going on is here you have 57 degrees. This is our tree. This is our person standing there. And the base of that triangle is 30 feet. So I started writing degrees, but that was feet. Okay, so this is our unknown. I don't know what letter you might want to call it. I'll just call it A. And so what I have is we have the opposite, we have the adjacent, and when I mean opposite and I mean adjacent, what we're talking about is in relation to our angle. So opposite 57 is that height of the tree, and then adjacent is 30 feet. So then what we need to do is we need to think, okay, what trig functions tie in opposite and adjacent? And what comes to mind is that tangent 57 degrees, or tangent, is opposite over adjacent. And we're trying to find A. So in this case, it works out pretty well that I just multiply both sides by 30. And I get the answer. And then, you know, it's a little bit unsatisfying. You could say, well, 57 is pretty close to 60 degrees, and tangent 60 degrees using right triangles is rad 3. And then you could start thinking, well, rad 3 is about 1.7. So now I feel like I sort of could do that in my head. I'd say it's going to be 51, around 50 feet. So, but let's take out the calculator, because that could, you know, it's more fun, right? The problem is I haven't done the calculator lately using, no, I haven't. So the problem is that I have to make sure my calculator is set on degrees, and I do not think it is. So I need to say I have the TI-83 calculator. Let me start from the beginning. So here's a TI-83 calculator. I am going to go to mode. I had it and then I lost it. Oh, here's mode. And then I go down to where it says radians, and I'm going to toggle over and highlight degrees. So, you know, units are really important, so we don't want to get the units wrong. So then I'm going to write 30 times tangent. So they have, no, anyway, here's tangent. And then I'll just put in 30. And I'm, okay. And now I don't know why I put 30. Because I was thinking of other things at the same time. Okay, keep in mind that tangent of 45 degrees is 1. And 57 degrees has a longer opposite than it does an adjacent. I mean, this picture here is meant to be sort of accurate, so that, or not that accurate, but still, the height is, the opposite is longer than adjacent. So this ratio of tangent is going to be greater than 1. So our answer should be greater than 1. And we get 46. So I was trying to do something in my head, and I said, well, it's around 50, but that turned out to be not really that good of a, let me round it off to 46.2 feet. I have this other book, they were talking about rounding, that you could round to one more decimal place than your input. So I'm going to do that. Okay, again, here's this person. They started the base of the tree. They walked 30 feet away. They have some measurement device that measures the angle between the horizontal and the line to the top of the tree, and that's 57 degrees. We look at, what are we trying to find? We're trying to find A, the height of the tree. Maybe H would have been a better letter. Yeah, probably. So we're trying to find that I'm calling it A. It's opposite over adjacent. Because I have opposite and adjacent, that gives tangent. Yeah, there's a bunch of other letters might have been better than A, but anyway. So I'm going to do opposite over adjacent, which is A over 30, and that's the tangent, 57. Multiply both sides by 30. Put in the calculator, make sure your calculator is set in degrees.